Hi and welcome. Today we're going to be talking about the trapezoid rule. It's written at the top here, and it says the integral from a to b according to the trapezoid rule, which is an approximation of area, is delta x over 2 times by f of x0 plus twice f of x1 plus twice f of x2. And you keep doing the twice f of x all the way up to x of n minus 1. Then finally you have a single f of x sub n. Here delta x is the usual suspect of b minus a over n, and x sub I is given by a plus I times delta x. The error bound is very similar to previous ones we've seen, but its denominator is slightly different. It's k times b minus a cubed divided by 12n squared, where again the k is given by a bound for the second derivative. And in this example, we're going to approximate the integral from 0 to 1 of 13 times by this cosine of x squared. Now, we're going to get started here, and the first thing that we're going to note is that this delta x is going to be b minus a 1 minus 0 over 4. So that's going to be a quarter. And this is going to tell us, hey, x0 is equal to a, which is 0 itself. And then x sub 1 is going to be 0, which is a, plus I times delta x. So we can write, hey, x sub I is going to be a plus I times delta x, which is going to be just I times 1/4. So when I is 0, we get 0. When I is 1, we get 1/4. When I is 2, we get a half. When I is 3, we get 3/4. Then finally, x sub 4 is going to be 1. Okay, now we're ready to proceed. So the trapezoid with four trapezoids is going to be 1/4 divided by 2. That'll be an eighth. Times by f of 0 plus f of 1, and that's, twice f of 1/4 plus twice f of a half plus twice f of 3/4 plus twice times f of, plus just a single f of 1. And I'm going to write that on one line. So plus f of 1. Remember, f of x is what's inside this integral. So that's 13 times by cosine of x squared. So this is going to wind up being 1/8 times by cosine, 13 times the cosine of 0 plus 2 times 13 times this cosine of 1/4 squared plus 2 times 13 times this cosine of 1/2 squared plus 2 times 13 times this cosine of 3/4 squared plus just a single 13 times cosine of 1. Okay, and when you do all of that and you add it up, you're going to get an approximation which is 11.64. Okay, so when you evaluate that, add it up, perform all the multiplications, you'll get approximately 11.64. Okay, so you might ask this question, how accurate is this? I'm going to use this error bound for the trapezoid, which says the error is less than or equal to k times b minus a cubed divided by 12n squared. Okay, so we've seen this is the process for determining the value of k. We have f double prime, and its absolute value needs to be less than or equal to k. So we start calculating derivatives. We calculate f double prime in the bottom here. So that'll be f double prime. Then I take the absolute value of f double prime. I take the absolute value of each term. I see each term is less than 26 and 52. I add those terms together, and that's the value of k that I use. Now, for us, we just need to plug in the values for that trapezoid rule now. And so the error for the trapezoid rule is less than or equal to k times b minus a cubed divided by 12n squared. Okay, and that's exactly what we have written up there. K is going to be 78 in this instance. 1 minus 0 cubed, that's going to be 1. 12 times n squared, n is 4. Okay, so we just need to compute that number. And I think we're going to get approximately 0.406. So this answer that we get, the answer of 11.64, is accurate to the true answer to within at least 0.406. Okay, and that was our lesson on the trapezoid rule. Thank you.